Okay, now let's walk through one more example. Given a Boolean expression, draw the circuit diagram. So again, let's go through the standard process. Ask ourselves, okay, how many inputs are there? Okay, and how many outputs are there? So look at this expression. Okay, this constitutes your count the number of different alphabets are there, and that represents number of different inputs. So A, B, X, Y, and Z. So wow, there are actually 5 different inputs, 5 different alphabets. So 5 inputs. Okay, and so bear that in mind. Z is your output. Okay, so let's start to draw that. Let's put our inputs on the left side: A, B, C, X, Y. Okay, these are all my inputs, and remind ourselves we want to arrive at the outputs. So before you start drawing, again, ask yourself on a high level, okay, what is the eventual outcome you're trying to achieve? You're trying to achieve something and with something and with something, right? Okay, so which leads you to conclude that at near the output stage, near the end of the diagram, near the Z, okay, Z, near Z, there you should be having a AND gate. This is one set of input, this is another set of input, this is another set of input. So a 3 input AND gate. So let's draw that 3 input AND gates. Okay, 1, 2, 3. Okay, one of the input represent this, one of the input represent this, another input represent this. Okay, so this is kind of reminding yourself this is what you are trying to arrive at eventually. Okay, so then let's work on the individual item. Okay, let's work on the first part. Okay, let's clear up this thing first. Okay, let's work on the first part, which is this. Okay, A plus B, I think that is a piece of cake, right? So A plus B, you to work on a plus, to draw a plus means you draw an OR gate. So you draw an OR gate, and the inputs are A and B. So you can indicate here, this is A plus B, correct? Yeah. So great, you have one of the inputs ready to be fed into the eventual out stage, the next stage. So let's work on the next stage here. Oh, I need to work on X plus Y, and then you invert the entire thing. Okay, X plus Y, invert the entire thing. So before we work on this inversion, let's work on what is easy first. The X plus Y portion. X plus Y portion is easy, so you just draw a X plus Y. Use an OR gate. That will represent your X plus Y, isn't it? Okay. That will represent your X plus Y. Now, then, bear in mind that it's not the end. You need to invert the entire thing. Okay, so this is the entire thing. This is the entire thing. You need to invert the entire thing. So what do you do? To invert the entire thing, you need to use an inverter. So the entire thing, you invert it. This entire thing, you invert it. So X plus Y, you invert the entire thing. And so great, that is another part of the AND gate you can connect to. And you left with last part, which is C. Okay, C, simple, nothing to be transformed. So C remain as C. And so that is your final output Z, okay? And that is the diagram, okay? And of course, you can verify. Again, let's just, for good practice, to make sure you score perfect score for this type of question, you can verify. And so to verify, you can, let's just kind of erase away our working and then try to verify. So you got okay, so let's try. Let's transform ourselves. You got A, you got B. Oh, go through a OR gate. This is an OR gate, so that becomes A plus B. So you can just copy that down here. This is my A plus B. No, I'm not changing anything. Just this is my A plus B. Okay, and C, nothing changed, so I'm just copying it down. C, and here, okay, X and Y, X, Y, you go through an OR gate, so that becomes your X plus Y. Okay, then you need to go through an inverter, so you transform invert the entire thing. Yeah, so x plus y invert the entire thing. So therefore here will be x plus y invert the entire thing. No change from here to here. Okay, so and you can see z is equal to something, and with something, and with something, because this is a 3 input OR gates. And what is that 3? What is that something? The first one is this. This is that something. This is next one is this. Okay, this is that another something, and this is your c is this part here. So correct, you have exactly the same expression as you do your transformation process. It is confirmed correct. Thank you. And so that is another illustration of how you would draw a logic circuit diagram given a Boolean expression.